morning and happy Tuesday 10 at 10. I am your host, Richard Charpentier, and every week we get questions sent from the bakers answered by a baker. And as you can see, we're in the crop season now. It's July, so I put some beautiful wheat kernels in the background, and before those are being transformed into flour. So let's get started. The first question is on dough volume. And the question is, can you give advice on dough? Basically, they're starting to have a nice volume on the bread dough. And as the dough ages, they're losing volume. And they're saying that most of the bread at the beginning will get about 4 inches, and then as the day progresses, it's 3.5 inches. So what could be going on? To be quite honest, not knowing what your formulation is like and the temperatures, because baking, as we all know, is all about time and temperature. So it seems like it's over fermented doughs, and over time, maybe overmixed. Maybe the flour you're using is too weak. And if as a rule of thumb, I've learned that it's never one thing. It's never just the flour. It's often a combination of different factors that will contribute to your loss in volume. So, is your dough overproofed? How do you check to see if it's proofed properly? Do you have any, dough conditioner that you're using that could potentially over time affect it? Do you have any reducing agents in your dough? So, those are all the questions going through my mind at the moment to think what could be, the cause and effect, where you're seeing a loss in volume. Are you underhydrated? Are you overhydrated? So it would require more details for me to really gauge and see where the issue could be coming from. But excellent question, and I wish you the best, finding the answer. Then we have a question on farinograph. And do you know why there are 3 curves on the farinograph? I know last week we talked about the alveograph. The farinograph has 3 points. It's basically, if you see on the curve, there's the arrival time, and the arrival time is to the nearest half minute from the first addition of the water until, for the top of the curve, first intersect the 500 BU Brevender unit consistency line. And it's also referred as the hydration time. So that's the first one. Then you get the peak time, and this is the time to the nearest half minute from the first addition of the water to the development of the dough's maximum consistency, and immediately before the first indication of weakening. And basically the peak time is the time needed for the curve to reach maximum dough consistency. And then you do have the departure time. The departure time is the time to the nearest, again, half minute from the first addition of the water until the point where the top of the curve leaves the 500 BU Brevender unit, and it indicate basically the flour or for the stability. So when you take all that, they can generate the MIT, the MTI, sorry, not MIT, MTI, the mixing tolerance index, and it's the difference in Brevender units from the top of the curve at the peak of the top of the curve, measured 5 minutes after the peak is reached. And then it's indication to see how strong of a flour, and then from there they can get the stability of a flour. So you'll get your reading, you'll get your MTI, mixing tolerance index, and your stability. The stability is given in minutes, and then it translates if you take a flour to see how strong it is. And, and then you can see if you're stability starts shrinking, and then you know that you have a weaker flour, and then therefore you would need to adjust at a bakery, maybe mix time, and either increase or decrease to find optimum mixing time and also optimum hydration for dough. So, but I hope it answered your question. And if you want more information on analytical tools used in the bakery and how to read them, I highly recommend to go to Bakeropedia main page, where I will type Farinograph or Alveograph or Mixograph, and then there's plenty of free information and very useful information that you can share with your group. Print it and then read it later on. But great question. So for our next question and last question of the day, we are discussing croissants. And the question goes that they proof croissants 75% of the time, and then they freeze it blast frozen, and then it's being used baking and finish. You know, it's partially proofed. But what they're seeing is that the croissants over time become smaller, and as the longer they stay in the freezer. And why would it be? It's also the amount of time you're proofing, and maybe you don't have enough ingredients to basically stabilize and keep your volume. Remember, as you proofing, you're generating volume through the release of carbon dioxide or CO2 being released by the yeast. And in your case, you know, what is the temperature, the internal temperature of the croissants before being frozen? And that variation can also create problems. But remember, as the volume increases and you're going into a freezer, it also could be how quickly or how slowly you're freezing your croissants, because then the expansion can, you know, the water will turn into water crystal, and the crystal will over time also lose moisture. Your croissant will lose moisture within the freezer. And then how do you package, you know, your croissants, and how are they packaged, and how well stored? And always in products, when they're being frozen, you can see that in any freezers or any refrigerator or any rooms, temperature is never constant. Even in the freezer, you'll see curves, it changes. So that could also be contributing to your problem. And again, what size, what's your throughput, how many croissants are you storing, and how many, you know, how often do you take them out? Is there a change of temperature, temperature and pH of the internal croissants can be also determined as a factor. But that to me is a project that will require more R&D time to pinpoint the real issue of why you have that, and find ways to fix the issue through, again, good product development and finding the right solution. And I'm sure, you know, it can be done. But that was a great question. So that's it for today. Thank you very much for listening to Tuesday at 10 at 10, and I will see you next week. Happy baking to you all. Thank you. Bye.